Hi, everyone. My name is Chelsea Render, and I am the Industrial Marketing Lead for AI and Machine Learning here at Amazon Web Services. I'm excited to talk to you today about optimizing industrial processes with machine learning and AI. All right, we will go ahead and get started. So everyone has heard the term Industry 4.0, also sometimes referred to as the Industrial Internet of Things, which is the next revolution for industrial customers. But we're at a really exciting moment with machine learning and artificial intelligence and digital transformation in general across asset-heavy industries. There are common themes across these industries like manufacturing, transportation and logistics, agriculture, power and utilities, energy and mining, that have meant that these are domains that have made it challenging at times to leverage some of these most advanced technologies like AI and machine learning. Some of these challenges include things like data access or integrating data from multiple machines with hundreds of different machine communication protocols, on-premise software applications, and automation system vintages, data management, with abundant unstructured streams of machine data that can be difficult to organize, security in terms of exposing security risks as industrial settings are often connected to external environments, scaling to manage industrial assets, device fleets, and data across sites, and potentially from remote sites with limited connectivity, and finally, real-time decision-making, given that customers often have minimal tolerance for latency on decision-making due to the speed of production in many cases. However, the opportunity for AI and machine learning within this domain is really high. A couple key workloads that we're seeing a lot of innovation around from our customers, particularly with machine learning, are in a few specific domains. In the engineering and design domain, AI and machine learning can be used to accelerate time to market, lower infrastructure costs, and improve collaboration. For production and asset optimization, this is about how can we lower costs, whether related to energy, machines, or labor, improve machine or asset productivity, or reduce production downtime. Sustainability is also an area where AI and machine learning are having a big impact as well. This technology is helping customers to lower cost and reduce waste, and even help identify areas for process improvement and mitigate consumption of water, air, gas, electricity, and steam. For smart products and services, this is all about unlocking field IoT data to accelerate business growth and engaging your customers digitally for new services, an enhanced customer experience, and improved loyalty. And finally, for supply chain management, obviously this has been an area for technology innovation for a long time, but we see in this area an opportunity for improved forecast accuracy, reduced inventory costs, and improved capacity utilization. The reality is that there are, of course, thousands of use cases within these workloads where AI and machine learning can come into play and help customers to digitally transform. But there are some use cases that are beginning to rise to the top as areas that are becoming more commonly adopted and readily available to implement and are really delivering real results. So today I want to focus on 4 of those use cases where AI is having a huge impact for customers today. These include improving asset performance by reducing unplanned downtime, automating visual quality inspection, improving operational efficiency at the edge, and forecasting demand and managing inventory. These are 4 areas where applying machine learning and AI to the vast amounts of industrial data created by systems, sensors, and assets can help you to better understand and leverage your data to run your business more efficiently. It allows you to quickly and easily transform data into insights that can help to proactively address breakdowns, shortages, and other challenges, and trim costs by reducing downtime, streamlining infrastructure, and improving quality assurance. So let's start by diving into improving asset performance by reducing unplanned downtime. There are 3 different stages that many industrial customers experience when it comes to asset maintenance. The first is reactive, or fixing it when it's broken, which can mean really expensive downtime. In the planned maintenance phase, you're scheduling maintenance activities to avoid downtime, but that may result in downtime when it may not even be needed. And then that third phase is predictive maintenance, which is advanced analytics and sensing data to predict machine reliability. This means that we're looking at detecting anomalies, diagnosing the root cause, and then predicting the remaining useful life of that asset. And moving from a reactive or a planned model to a predictive model has significant upside for customers. According to one study by McKinsey, predictive maintenance can reduce maintenance costs by 18 to 25% and increase asset availability by 5 to 15%. So how? Well, first, by preventing failures, breakdowns, and downtime. Knowing when something needs to be repaired or what needs to be repaired and where at the right moment can reduce the overall downtime that you have on something like conveyance systems. Minimizing risks. That one seems fairly obvious, but if you're working in a dynamic environment where things are constantly changing, being able to minimize and manage your risk across your machinery at scale can be really valuable. Preventing quality issues. If you have a piece of equipment that is malfunctioning and you are not aware of that in sufficient time, that can potentially impact quality of your final product, for instance, coming off of a production line, which in turn, of course, impacts cost as well if you have to scrap or rework product due to quality issues. And then other areas include minimizing recalls, warranty claims, liabilities, and SLA breaches, optimizing inventory and resources, and of course, minimizing maintenance and repair costs. That said, predictive maintenance traditionally can be difficult to implement. And some of the challenges include needing to monitor many different types of equipment for different applications, all in different environments, which can be really costly to implement. And many times those solutions require installing expensive sensors, building infrastructure to securely capture and transfer that data, and then analyzing that sensor data for potential failures, which can require software development capabilities and data science skills. Where machine learning can help with those challenges is that it can be customized to learn the performance of a specific asset in a specific operating environment, and then automatically find relationships that define asset behavior. It can analyze many complex relationships at once and update automatically. And most importantly, it can now be done in the cloud with low-cost infrastructure usage and specifically design services. One solution to these challenges that Amazon launched a few years ago for customers who want to get started quickly with end-to-end condition monitoring for industrial equipment is called Amazon Monitron. Amazon Monitron is a system that includes wireless sensors, a gateway device, and a mobile or a desktop app so that technicians can easily track and review developing faults. And the best part of this is you don't need any data scientists or even machine learning expertise to use it. So let's look at how that works. First of all, to get started, you can purchase an Amazon Monitron starter kit, which includes 5 sensors and 1 gateway, easily on Amazon.com or Amazon Business, and they work right out of the box. You can easily and quickly set up the Amazon Monitron wireless Bluetooth sensors using near-field communication with the Amazon Monitron mobile app. The sensors, once installed and set up on your equipment, capture vibration and temperature data from your unique equipment, and then transfer that sensor data to the cloud via the Amazon Monitron gateway. The Monitron service then automatically analyzes your sensor data using machine learning and vibration ISO standards to create a unique ML model for your machinery. You can then view notifications on abnormal equipment condition in the Amazon Monitron mobile or desktop app and take action. You can also give feedback on those alerts directly in the app, which helps to continuously improve the machine learning model performance. Amazon Monitron enables you to implement predictive maintenance for rotating equipment, such as motors, gearboxes, pumps, bearings, compressors, or fans. Essentially, any continuously operating rotating equipment in your industrial facility where vibration and temperature are the key metrics that you want to measure. So here's a photo of an example environment where Amazon Monitron might be used. And in fact, Amazon uses Amazon Monitron in Amazon fulfillment centers on the miles and miles of conveyance systems to monitor anomalies so they can avoid unplanned downtime and make sure that customers receive their packages on time with no disruption. And here's an image of a wireless Monitron sensor on an asset. And by the way, you can also check out a more detailed video that is on YouTube about Monitron being used in Amazon fulfillment centers if you want to see more details on that. But let's say that you've already made investments in equipment health monitoring, and maybe you already have robust data on your machinery from various sensors and systems. Maybe you have thousands of sensors across many types of complex equipment in multiple locations. In that case, you may not need an end-to-end system that includes sensor hardware like Amazon Monitron. You just need a scalable way to analyze that data that you already have to find insights that help you maintain your equipment more efficiently. Traditionally, this has been one of the more challenging aspects to implementing predictive maintenance in everything from managing sensors, figuring out the data storage, connectivity, analytics, and then analytics visualization. In these cases where you may have many unique assets with not many examples of downtime in the past, you really need a solution that can be customized to your unique data, that doesn't require that data to have many labeled examples of failure, has the capacity to be adjusted over time, is scalable, and ideally doesn't require any machine learning experience to use it. For these cases where you've already invested in your own industrial sensors, but you want to get that same benefit of automated machine learning to get insights from that data, one solution from AWS is called Amazon Lookout for Equipment. Amazon Lookout for Equipment is an automated machine learning service that uses your sensor data to detect abnormal equipment behavior. Lookout for Equipment will use the data that you already have from existing sensors, systems, and historical logs to automatically train a machine learning model. It will learn the healthy state and operational relationships between sensors on each asset and analyze incoming sensor data to automatically alert you of equipment anomalies so that you can take action. And of course, no machine learning expertise is needed. So how does it work? In a nutshell, you bring your data to Lookout for Equipment, and it will model the behavior of that equipment to be able to tell you when normal behavior is happening for that equipment or alert you to any abnormality in the behavior of a specific asset. On the left on this slide, you can see an example of a mess of time series data for various sensors on a complex asset. And then after Lookout for Equipment builds that custom model for you, it'll be able to tell you whether everything is operating normally and you don't need to take any action, or whether an abnormality has been detected, and it'll give you that rank order list of exactly which sensors are telling us what's happening. All of this is to really help your technicians really laser focus on any potential issue so that you can take action in the right place at the right time to be able to avoid any issues. So we've just talked about a few options for enabling predictive maintenance with machine learning, but how are customers actually using it? Well, one customer who's been seeing success with Amazon Lookout for Equipment as well as Amazon Monitron is Koch Ag and Energy Solutions. They were looking for a way to detect potential failures of industrial equipment, such as compressors at a nitrogen production facility. After implementing Amazon Lookout for Equipment, the service alerted to a potential issue with a compressor hours before any other monitoring method that they were using. The compressor and temperature deviations were confirmed by their specialist, which allowed them to address the issue promptly in the short term and develop a long-term plan for maintenance activities. Overall, this allowed them to avoid potentially expensive downtime and any impact to production. And by the way, there are also AWS partners that can support you in implementing predictive maintenance solutions if you need or want any implementation help, or if you have a need for more customization for your unique use case. Some of these partners include Radix, Siemens Energy, Syntax, Decision IQ, Tensor IoT, Rovasys, Seek, and OSIsoft. You can also find more about these partners and how to get in touch with them on our website, which I will share at the end of this Tech Talk. Now, moving on to the next use case for machine learning and artificial intelligence for industrial and manufacturing, which is automating visual quality inspection. Now, this has been an area that has long been an area of interest and innovation for researchers in machine learning and across the technology sphere. And this is because many organizations have true quality-related costs as high as 15 to 20% of sales revenue, according to a study by Aberdeen. So there's a big need here to improve quality control processes, and that probably isn't a surprise for many of you on this call. What might be a surprise is where we are right now with what's possible with computer vision and computer vision technologies. When we look at the types of visual quality inspection problems that our customers are trying to automate, there are two modes of operation today as current state. The first is manual inspection, where you have people standing in line during a production process inspecting output as it comes down the conveyor belt or the assembly line. Or you may have manual end-of-line inspection, where after the goods have gone through the production process and they're in the staging or warehousing area, people are manually inspecting the quality to determine whether or not they meet the standard. The second approach that we see is customers are leveraging machine vision solutions that deploy inline or offline to automate the process of quality inspection. But these machine vision solutions tend to be proprietary, and they're often really expensive to the extent that it's difficult for customers to scale them to multiple points along the production process, and thus improving their capacity to ensure high quality product is produced at each stage of production. And the challenges that we see for customers who want to implement computer vision themselves is that leveraging computer vision at scale requires really unique skills at each stage of that development process. Customers first have to create and train a custom computer vision model that is designed not only to identify the products that are being produced, but also be able to classify products according to their quality, and in some cases, the specific type of defect that that product may have. The next step in that process is for customers to take that model that they have trained and be able to deploy those and set up a media inference pipeline that allows them to get new data off of the production line and ingest that data into the model that they have built. And then ultimately, many customers find that those models evolve over time, and so there's effort that they have to take to sustain and support and maintain these models such that they maintain a high level of accuracy and performance as they are continually used in the quality inspection process. A service that Amazon developed to help customers overcome these challenges is called Amazon Lookout for Vision, which allows you to automate quality inspection by spotting product defects with computer vision. And some of the benefits here include improved defect detection speed, consistency, and accuracy compared to manual inspection, a lower cost of quality control inspection compared to machine vision systems, a very fast time to get started, as you can get started building a model with as few as 30 images, and no machine learning experience is required. So let's take a look at a few examples of the kinds of defects that Amazon Lookout for Vision can help you to find. One defect type could be a tiny scratch on something like a printed circuit board, which you can see in the upper left. Or it could be the absence or presence of something, or misalignment or placement of an object, such as a missing product in a blister pack seen on the upper right. Other examples that you could use this for are shape defects, such as improper soldering on a printed circuit board, or identifying consistency changes in steel coils, for example. So let's take a little more detailed look at how Amazon Lookout for Vision works. It starts with capturing and processing and loading training images from your production line into AWS. So with as little as 30 images, you can upload those into Lookout for Vision, and you label those images to indicate whether they're good examples of good products or poor quality product. Based on those at minimum 30 images that you've uploaded and the labels that you've applied, Lookout for Vision automatically starts training a custom machine learning model that is specific to the units that you are producing, and it tunes that model to reach the desired level of accuracy. Once that model has been trained, then you can deploy it and run new images from the production line through your model. And in real time, you can use a dashboard that's built into the service to monitor the predictions and inference results of that model against your new data. And where necessary, you can correct a label that's been applied by the model to indicate whether it is an anomaly. The service learns from those human applied labels and then automatically retrains the model and continuously improves it to maintain a high level of accuracy. One example of a customer who has been seeing success using Amazon Lookout for Vision for quality inspection is Tyson Foods. Tyson Foods, as you may know, is one of the world's largest food companies and a recognized leader in protein and processes millions of pounds of food each week. Tyson Foods developed a solution to identify faulty plastic pins or shackle pins that hold product carriers in place in its poultry production facilities. Previously, employees needed to manually inspect nearly 8,000 pins per line every shift because safety issues or unplanned downtime could occur if a pin fell out of place. So to automate this process, Tyson Foods used Amazon Lookout for Vision to create a custom ML model to analyze images and detect anomalies for the shackle pins. They deployed the model at the edge on an AWS Panorama appliance, which allows them to do all of this at the edge or locally so that its employees are notified right away that a product carrier needs maintenance when the model identifies anomalies. With this solution, their team members no longer need to spend an estimated 1 hour per shift per line inspecting product carriers, which is estimated could save the company 15,000 hours of skilled labor annually in a single facility. All right, so let's jump into the next use case for computer vision powered by machine learning for the industrial space, which is improving operational efficiency at the edge. So we already spoke about one use case for computer vision powered by machine learning, which is evaluating manufacturing quality by quickly detecting anomalies. But there are many other areas where computer vision and machine learning can be applied in the industrial space to provide value as well. One of these use cases is improving supply chain logistics by tracking throughput or optimizing supply chain operations by recognizing parts or products or reading text on labels and barcodes. You can also optimize traffic management in real time, such as automatically monitoring traffic lanes for issues like stopped vehicles and sending alerts to staff to keep traffic flowing. Or you can use it to enhance worker safety in industrial environments by automatically monitoring whether, for example, a forklift has strayed into a dangerous off-limit zones, for example, and then sending an alert to someone on the floor who can take action. These are just some of the use cases that we are seeing our customers use computer vision for. But we're also seeing that they also need to do a lot of these things at the edge or locally close to where the data is being created. This is because many are finding that it can be difficult to implement and scale these solutions, especially in sites where limitations exist in connecting to the cloud or sending data offsite. These customers want to optimize their computer vision for the edge. Many use cases require real-time responses to what's being captured by cameras. For example, a pharmaceutical company may want to inspect vaccine vials on a fast-moving conveyor belt to validate fill levels. They really need sub-second response times here to maintain throughput, where a round trip of that data to and from the cloud might be infeasible. And then some customers operate in environments where there are bandwidth constraints related to cost or infrastructure or simply intermittent connectivity. And in those instances, it's either very expensive to send high bandwidth video streams back to the cloud, or customers simply don't have sufficient bandwidth to do that. They would prefer to be able to process all of this video data at the edge and then optionally send select data back to the cloud. And finally, customers operating in regulated industries may need to process data at the edge due to data privacy or governance concerns. And those customers have corporate security policies or regulatory requirements that restrict their ability to send video and image data back and forth to the cloud. So as a result of these constraints, customers are looking for a solution that allows them to capture and process image and video data where it resides at the edge. But many edge computer vision solutions can be difficult to implement. First of all, it can be expensive to replace all of your camera infrastructure if you need smart cameras with onboard inference capabilities. It can also take a really long time to get prototypes to production. There are a number of iterative steps that customers had to take as they were building models to ensure that they would work at the edge and be as performant and compatible on their edge platforms as they are in the cloud. And even if you're able to overcome all of those challenges, scaling devices to hundreds or thousands of devices can be difficult due to managing all of the underlying security, device management, and model updates that were required to not only deploy CV at the edge, but maintain and scale it. So to help our customers overcome these challenges, we developed AWS Panorama. AWS Panorama is a collection of machine learning devices and a software development kit that brings computer vision to on-premises Internet Protocol or IP cameras. Panorama hardware devices allow you to add computer vision to your IP cameras that weren't necessarily built to accommodate computer vision. You can analyze video feeds from multiple cameras in parallel and generate highly accurate computer vision predictions within milliseconds. Processing your data at the edge means that you control where your data is stored, and you can operate with limited bandwidth. And you can bring your own or select partner computer vision applications such as traffic management applications, people counting, worker safety, etc. There are currently 2 AWS Panorama device options to choose from with different features and price points. You can choose from the AWS Panorama appliance or the Lenovo ThinkEdge SE70, both of which allow you to run multiple models per stream and multiple cameras in parallel and can be set up in minutes. You can find all the specs and more information about these devices on our website. And as we mentioned previously, there are, of course, a variety of AWS partners that can assist you with implementing computer vision at the edge, depending on your needs. These include app and solution builders such as Deloitte, TensorIoT, Pilot AI, BigMate, Provectus, TaskWatch, Tata Consultancy Services, and Accenture. Panorama device OEMs such as Axis, Lenovo, and NVIDIA, and hardware systems integrators such as Stanley Security and Convergent. So let's talk about a customer who has seen success with using AWS Panorama and computer vision at the edge. The Vancouver Fraser Port Authority, or VFPA, is Canada's largest port responsible for facilitating Canada's international trade. They had a need to enhance supply chain efficiency of their shipping container inspection process. And this was because reliable information on actual container examination operations was limited. Many processes were manual and information was distributed across multiple organizations. So they worked with AWS partner Deloitte to implement computer vision at the edge using AWS Panorama to be able to increase visibility of their container inspection process. And that meant that the port's customers and stakeholders were able to get accurate, real-time information on where any container was in the container inspection process. With AWS Panorama, they're able to do all of this using their existing IP camera infrastructure as part of the solution and run computer vision models locally at the edge, even with limited bandwidth and requirements for data residency. And last but not least, as the last use case that we will cover today, we'll talk about forecasting demand and managing inventory. Many companies are facing the reality that customers increasingly want more variety, they want it cheaply, and of course, they want it immediately. Add that to a very complex and extremely dynamic global market, and many companies are struggling to understand how to give that product availability at a lower price and with quick delivery. The challenge is that forecasting future business outcomes such as product demand, resource needs, or financial performance can be really tough. Companies today use everything from simple spreadsheets to complex financial planning software in order to do this. These tools typically build forecasts by looking at a historical series of data, which is called time series data. For example, these tools may try to predict the future sales of a raincoat, for example, by looking only at its previous sales data with the underlying assumption that the future is determined by the past. But that approach can struggle to produce accurate forecasts for large sets of data that have really irregular trends. And also it fails to easily combine data series that change over time, such as price, discounts, web traffic, or number of employees, with relevant independent variables like product features and store locations. Increasingly, market leaders are investing in machine learning-driven forecasting to more effectively meet demand. A service that Amazon offers to help with some of these challenges is called Amazon Forecast, which is a time series forecasting service based on machine learning, and it's built for machine metrics analysis. Amazon Forecast includes algorithms that are based on over 20 years of forecasting experience and developed expertise used by Amazon.com. It's a fully managed service, meaning it automatically sets up the data pipeline, training, and prediction for you. It builds a model for your unique data, and it's really highly accurate. It can have up to 50% improvement in accuracy over traditional non-machine learning-based methods. And of course, like many of our managed AI services, no machine learning experience or deep learning experience is required. For industries like manufacturing and distribution, Amazon Forecast can help you do things like minimize inventory carrying costs by meeting demand with lower safety stock at all points in the supply chain and free up working capital, or reduce rush fulfillments by positioning inventory throughout your distribution network in anticipation of demand. One example of a customer who has been using Amazon Forecast for a somewhat unique application for predictive maintenance is Arnig, who is a global leader in commercial refrigeration manufacturing. To facilitate food safety for their supermarket customers, Arnig needed to provide around-the-clock customer support worldwide every day of the year. And in the past, they used an interactive remote information system, which was a locally hosted application to manage alarms, service calls, and on-site work. But with that system, refrigerators would send alarms to Arnig when they were malfunctioning, but only when the units could not maintain the strict commercial refrigeration industry standards. And that meant that their reaction times were very short. So they developed a predictive maintenance model using its Internet of Things infrastructure and Amazon Forecast, which issues a notification before an event is likely to occur. And that gives their service teams time to monitor the equipment and notify on-site maintenance personnel in advance when necessary. It allows them to provide better quality service by preventing refrigeration unit breakdowns in the first place, and helps optimize the cold chain, improving efficiency and energy savings for their retailers while facilitating food safety for consumers. And so far, that predictive maintenance model predicts maintenance needs with over 80% accuracy. And what we've covered so far today are some of our AI services that allow you to implement machine learning easily with no machine learning experience required. But I also wanted to briefly touch on Amazon SageMaker, which is another option for many of these use cases if you want something that is a bit more customizable for data scientists and developers that you may have on staff. Amazon SageMaker is a general purpose machine learning service that you can use to build, train, and deploy machine learning models for virtually any use case, and it provides an integrated development environment, or IDE, for machine learning. Here you can see some of the more common use cases for SageMaker for industrial and manufacturing customers, such as computer vision, predictive maintenance, demand forecasting, autonomous driving. But of course, there are many, many other use cases that you can use SageMaker for as well. One quick example of a customer using Amazon SageMaker is Engie, who partnered with Mangrove, which is an AWS advanced consulting partner specializing in machine learning in AWS services in France, to improve their predictive maintenance models. And by doing that, that resulted in an estimated savings of 800,000 euro per year for the group's business units that adopted predictive maintenance that was a result of this process. Love seeing customer success like that. So that is it for us today. Thank you so much for joining me today to chat about industrial AI and machine learning use cases. And if you want to learn more about any of the use cases or services that we discussed today, please check out this website address. It's aws.amazon.com/industrial/machine-learning. All of the use cases we discussed, as well as links to all of the specific services that we talked about, are linked from that site. Or, of course, please feel free to reach out to me. Please connect with me on LinkedIn if you like, and I would be more than happy to connect with you there. And now I am happy to take any additional questions that you have in the chat. Thank you.